Today, we are beginning a civil engineering design project, similar to real-world engineering. Our project requires strong teamwork, research, design, building, testing, and communication. However, before we can dive into the design, build, test stages, let's start at the beginning and gather some information about the project. First, let's review the civil engineering design process, which is a specific set of steps that engineers use to organize their ideas and refine potential solutions to engineering challenges. The steps include recognizing the need, problem definition and understanding, project planning, schematic design phase, design development phase, construction, document phase, and construction administration phase. Following this process, we start out by identifying the need for our engineering project. Instead of asking what do we want to design, we ask why do we want to design that and what the problem and to need will our design ultimately be solving. Group 1 is planning for the construction of a condominium building. Step 1. Recognizing for the need of the building. The company began to focus on the development of mixed-use communities, primarily for the middle-income market, by commencing the development of its Eastwood City Community Township. In addition, the company engages in other property-related activities, such as project design, construction oversight, and property management. In 1999, Eastwood City Cyber Park became the first IT park in the Philippines to be designated a PEZA Special Economic Zone. For the public sector, there is a massive expansion of residential buildings that are being constructed from Cavite to Bulacan. This building would face the need for the home spaces. The development of cities makes a place denser. Therefore, more spaces are needed to accommodate the human density of an area. It helps us to sufficiently give space and shelter for individuals that an individual could afford based on their income as a middle-class employee. This project gives and would generate livelihood for the workers who would work and make this project come to life. Aside from this, the company's target market is from the middle-income earner employees and the member of the home development mutual fund, or in other terms, Pag-ibig Fund. Private sector would need this project and be funded by Mega World Corporation. They are a realty or a real estate company which are known to initially establish a reputation for building high-end residential condominiums and commercial properties located in convenient urban locations, with easy access to offices as well as leisure and entertainment amenities in Metro Manila.
Now, let us discuss step 2 of the design process, which is define the usage of the building. It also includes the problem definition and understanding. A project is a plan of work that ideally gets you to the desired outcome. Before a project takes place, you really must think about and define why you are taking on the project. What are the issues and problems you are having that the project will address? Or what problem or need will the project ultimately be solving? In this process, we were going to answer that questions. One approach we can use is the 5W approach. The 5 W's are what, who, where, when, and why. Let us first focus on the problem definition and understanding. According to Rappler.com and CNN Philippines, San Miguel Corporation on Tuesday, December 15, said the new Manila International Airport in Barangay Taliptip and Banbang, Bulacan, will begin construction in the first quarter of 2021. It aims to provide a new gateway for the country and ease congestion at the Ninoy International Airport and traffic in Metro Manila. The actual construction for the project can only start once President Rodrigo Duterte has already signed the franchise bill into law. Now let us analyze it. If there is a new airport, there will be new staff and new employees, but not all of them are living in the nearby area. and that is when the usage of the building comes in. With that being said, let us now proceed to the usage of the building. As mentioned earlier, there will be a new airport in Bulacan and it will need new employees and staff in the future, but not all hired employees are living in the nearby areas. So we thought of building a condo building for the employees and staff of airport coming from faraway places. Also, we want to dedicate it for middle-income earner employees and members of Pag-ibig Fund so that they can loan through Pag-ibig Housing. In simplest terms, we would like to build a condominium building to provide townhomes for employees and staff of the New Manila International Airport in Bulacan, and also for middle-income earner employees and members of Pag-ibig Fund. This building will be located in the nearby town at Doña Remedios Trinidad Highway, Pulilan, 3005 Bulacan. As the saying goes, prevention is better than cure. So in this slide, here are some key factors to consider before we begin construction to prevent problems that may arise. First is budget. It is important to first obtain an accurate construction cost estimate on the project before designing or even constructing it. Second is people. We can't stress how important it is to have the right architect and other professionals on board to help us with our project's design. Having a well-designed project will not only help add value to the property, but more importantly will help to improve the user's experience of the building. Selecting the right builder is also a must, but it can be difficult. For most people, referrals are normally the way in which they decide on the builder. But we must also consider the company history, project experiences, quality of past project completed, and visiting their current construction job site. Third is duration. Faster construction schedules can help building owners earn money on their investment faster by moving clients in sooner. It also leads to lower financing costs because shorter construction time means reduced interest charges. Time-related savings can easily amount to between 3 and 5% of the overall project value. Though speeding up project maximizes value, we must always remember that speed is achieved without jeopardizing safety. Next is sustainability. Sustainability refers to a building's overall ability to balance economic, social, and environmental sustainability factors in equal harmony, or in other words, to provide a comfortable, healthy, and productive environment over the long term without negatively impacting the environment. We need to ensure that when constructing, we consume natural resources such as materials, energy fuels, land, etc. at a sustainable rate. Last but not least is safety. As high buildings are inhabited by more people, greater measures must be taken to ensure its strength and safety, especially against climate change and natural hazards such as earthquakes, floods, typhoons, and more. Designs and construction site must be reviewed in depth and materials must be constantly tested on site. As building a high-rise structure is no easy task, a lot of engineers and architects are tasked to ensure that the most stringent standards are met. Technical codes and local regulations also have to be met in building skyscrapers. In the Philippine setting, the National Structural Code and the National Building Code govern. The two codes are often updated based on new findings, events, and comparisons with foreign counterparts. Many of the standards set have safety factors. This leads to slightly over-designed structures, making buildings stronger than expected. And that's it for the step 2 of the design process.
The next phase would be the project planning. This phase is essential for us to provide a complete approach for the housing site selection and development planning because this calls for the safety of the people in the community. This includes the holistic understanding to the importance of the planning considerations and factors that may influence the site selection, such as the cost and location, environmental impact, and traffic flow. This is also the part where the client selects an architect firm or a contractor to initiate the design process. The potential site for the building will be stated in this phase as well. As for this project, the potential site is located on the province of Bulacan. Considering the airport that will be constructed in this province, which is the New Manila International Airport, and the other commercial buildings within this area, the client prefers to build the residential building in this location mainly for the employees. For the specific location, it will be located along Doña Remedios Trinidad Highway, Pulilan 3005, Bulacan. Presented here are the pictures of the site and the satellite view of the location. Next will be the estimate cost of this project. It will have an estimate of 250 million pesos, and this estimate includes the site work cost estimate, which is presented in the picture, and the other costs such as the construction cost, documents, and other more. Another factor that may influence the site selection is the environmental impact. Construction of residential building like this has some built-in impacts that is either positive or negative. For this project, the possible impact that this development may encounter during the construction process are the following. Noise. This will be from the noise emissions that are generated as a result of various construction equipment, air compressors, and vehicles. The construction equipments and other sources will generate noise within the vicinity of the construction site. Next is the air pollution. This will be coming from the dust during the construction, use of vehicles on site, and resource depletion. The third one will be the solid waste. These are the waste from the construction process. It is generated from the construction activities, labor camps, sewage treatment plant, and other sources. The fourth will be the land use. It is because of the need to use the land for the construction of the project. The fifth environmental impact will be the changes in the land surface. That is mainly because of clearing of vegetation and excavating. The sixth will be the resource depletion, that is due to the extraction of resources for the materials to be used for construction, and lastly, fill problems due to the waste generation and disposal. The last factor will be the traffic flow. According to the Philippines News Agency, more than 292 million was released by the national government, resulting to the start of construction of several road projects in Bulacan. This budget is used for the reconstruction, maintenance, upgrade, and rehabilitation of drainage canals and roads, specifically on the Doña Remedios Trinidad Highway, that will diffuse traffic congestion on its own. That is why this project will be beneficial to the residents of this building because they will have easier access to the airport and the nearby establishments and commercial spaces without a problem about having traffic congestion.
Schematic design phase. The architect consult with the client to fully understand the intended usage of the building and to obtain the approximate budget for the project. The architect prepares multiple schematic design for the building or to translate the project program into a physical drawing of space. The client and the architect narrow down the option to one or two design to avoid possible errors or omissions. Schematic design contains layout of rooms and spaces, material type, framing system, and etc. Site plan. A drafted view of the location of the proposed project. So since our location is located from a major highway, pwedeng magkaroon ng mga traffic at kung ano man. So ang site plan dito dinidesign kung saan pwede maglagay tayo ng temporary road upang hindi maapektuhan ng construction ang major highway. It's a drawing that shows an interested party what the plans for developing land are. It is also considered as one of the key components in getting a construction project approved. Foundation design. Foundation is the base of any structure. Design of foundation depends on the type of soil, type of structure, and its load. Floor plan. Ground floor plan consists of a restaurant, reception area, bathrooms, and waiting area. For the ground floor finishes, lobby, restaurant, and waiting area has a ceramic tiles and a paint wall finish. For the bathroom, we use granite tiles and a paint finish wall. For our second to 10th floor, we have a studio type room with a length of 15 meters and a width of 5 meters and a 4 meter length of bathroom and 1.75 meters width. And for our room finishes, we use a engineered wood floor and a laminate wall finish. And for the bathroom, we use ceramic tiles floor and a waterproofing wall. Electrical plan. A pre-plan of electrical design on a paper before the physical installation of electrical appliances and machines in real time. Electrical plan also is a wiring diagram that visualizes and organizes the circuit and electrical system on a whole building to prevent power failures and electrical hazard. Fire protection plan. A detailed report of the life safety, fire safety, and evacuation system of a building. Fire protection plan consists of emergency evacuation plan, designated emergency response team, identification of a fire hazard, a fire prevention plan, a regular training and drills, and a preventative maintenance in order to limit the potential casualties.
I'm Jansen Rictias Tabales and I'm here to present Step 5, which is the design development phase of the building Sierra de Bulacan. The design development phase is the phase of the project that follows the schematic design phase. It culminates in the preparation of fully developed design documents as approved by the owner and its representatives in the preliminary schematic design documents. Moreover, it consists of design and other documents including plans, sections, elevation, typical construction details, and diagrammatic layouts of the building system to fix and describe the size of the character of a project as to architectural, structural, mechanical, electrical system, and other elements as may be appropriate. Let us proceed to the architectural design. The architect introduced the final schematic design and has chosen a modern look with a wood accent and vertical pillars to complement the exterior walls. Here you can also see the layout of each floor from basement to its rooftop. It is also in the architectural design where we can find specific dimension of rooms and elevation for each floor after the schematic design is finalized. Then, the structural engineer would decide what kind of structural framing the building would need. For our case, the engineer have decided to have a fixed-ended rigid frame structure for its structural framing. The structure of a steel rigid frame building is characterized by its rigid connection of straight or tapered columns and beams. These structures look similar to that of a post and beam system. The difference is its considerable ability to hold vertical loads without additional bracing due to the rigid connection of its members. The fixed-ended rigid structure is represented in image C, while the braces is included in the image D, which is represented by the diagonal lines. It is important to have a fixed-ended rigid structure since the exterior wall would be filled with windows. Another role of structural engineer is to decide on the placement of the columns. So as we can see in the presentation, our building is a 10-story building. Therefore, it needs 240 by 400 mm on the external columns and 250 by 800 mm on the internal columns, with both columns having a reinforcement of 3%. In creation of foundation, columns, and beams, the company will use a traditional method which involves cement reinforced with steel to provide tensile strength. In calculating the said column, the load are an important variable on this matter. There are two types of load that are needed to be considered. The live load, which are variables as they depend on usage and capacity. However, design codes can provide equivalent loads for various structures. Load prescribed by codes are empirical and conservative, based on experience and accepted practice, while dead loads, are also known as permanent or static loads, are those that remain relative constant over time and comprise, for example, the weight of the building's structural elements, such as beams, walls, roof, and structural flooring components. Other than that, since the company will only use bare finish for the other rooms, we have prepared a standard design room which includes the essential of the room as you can see in the presentation. After the interior design, let us now go to the system inside the building. The first is the HVAC system, which is handled by the mechanical engineer. The HVAC system focuses on the air circulation of the building by releasing hot air into the RTU. HVAC systems are often used in chilling and warming up a room, but since the Philippines is a tropical country, we could only use it as a chiller. So these are the air-conditioned ducting system that can be seen in each floor. Other than HVAC system, the mechanical engineers will also handle the elevators and water treatment piping, which includes the drainage and even the sprinklers. However, in order for the mechanical parts to move, we need electricity in our building. You can see in this presentation the design of electric flow on each floor. On the ground floor is where the power or control room is located. The electrical engineer will also compute the electrical load and the size of the wiring needed. Lastly, the company will hire a contractor to estimate the following material needed to build the said building. The company has chosen Monolith Construction and Development Corporation as its contractor. The estimated cost computed was 22,374,812 pesos. Here are some examples of the computation of the materials. The estimation was computed by calculating the area of the following rooms, ceiling, floor, and also the perimeter of the wall. These then are multiplied by the cost of the finishes of each, which include waterproofing, ceiling finishes, wall finishes, and floor finishes.
After the design development, a project requires to proceed in construction documentation phase. The construction documents comprise detailed drawing set that help contractors and engineers work on the project in real life. The schematic design phase introduces the concept for the project. The design development phase adds further practical components needed to complete the construction design process. Architectural drawings are used to create in detailed drawing that help the contractors and engineers to work on it in real life. After the design have been finalized, the focus shifts to building. These drawings are what will govern building process and should be heard and easily understood by the contractors. All the details regarding the project have to be here to allow for complete understanding of it. In case of any discrepancy or failure wherein sections have been redrawn and redesigned, The final construction document helps to reduce the time taken. Construction documents are the finalized design set that will govern the construction of the project and are translated into the technical language of the constructors. These construction drawings are used by the contractors to build a required component as intended by the architect and the client. The construction documents include the following: application of the building permit. Why? Because it allows you to legally begin construction on your home or building project. Having permit prove that your project drawings have been cleared and met all necessary specifications. It also gives you satisfaction that your new home or building improvement is safe and compliant. Design, specification, and drawings. A detailed document provides a list of points regarding to product or process, work of landscape architect plan, design and oversees creation, regeneration, and development of external land areas such as garden and recreational area, as well as residential, industrial, and commercial site, and also geoanalysis. The civil engineer provides the site plan design, which includes grading of the ground from the perimeter of building to sidewalk, grading of the parking area, draining for surface runoff, demolition plan, and the relocation of power lines as needed. Structural engineer must be in mind all design specification required by building codes as established by local government. All design and specification should be in line with the building code of the Philippines.
Good afternoon everyone, I'm Lana Estabaya. I'm going to discuss the step 7, which is the construction administration phase. This phase involves our architect monitoring the constructions to verify what it is happening in accordance with the construction document they are submitted or prepared. In construction administration phase, we have to consider first the contract administrations. Here, the general contractor will normally have an inspection process to ensure that the work of all the subcontractors is progressing as indicated in the contract document and that the work meets the standards of quality and workmanship. Like for example, in our project, we should have a team of quality assurance inspector generally assist the contractor's project superintendent. These inspectors are individuals who by training and experience are specialized in their own areas of construction. For example, in concrete, steel, or masonry. So, we need to have the laboratory to test the structural concrete used to the site must be verified for the strength and other properties by independent concrete testing laboratories. What we mean by strength there is like, for example, we have this 3000 psi, 2500 psi, 3000 psi, and it has a corresponding curing time like 7 days, 14 days, and 28 days. Second, the architect's observation of the constructions. We need their presence in the field of observation because allows the architect to verify that their drawings and specifications are transformed into reality, just as they had conceived. It also provides a sufficient safeguard against the errors caused by the contractors' misinterpretations of contract documents in the absence of the architect's clarification and interpretation. Third is the inspection of work. So we need to ask the architect for their inspection because they have the one to verify the substantiality of the materials and the completions of the materials for them to approve for payment. After the inspections work, fourth is the payment certification. Usually, the architects do the evaluation of the work as to the progress of the billing, because we have in this contract how many months or is it in progress billing, or in every 15 days, or monthly. It depends on the stated contract how to pay the contractor. So we need the payment certifications from the architect. So the fifth one is the change order. So we have to, as the developer, we have to consider the change order during the construction project, because sometimes changes happen, and the contract between us and the contractor recognizes this fact and includes provisions for us, the developer, right to order change, and the contractor's obligation to accept the change order in return for equitable price adjustment. So here, we have to agree how much the price needed for the adjustment. And note that the change orders refer to the minor changes in the project, and whatever projects needed and requires in the construction has significant modifications, the contract must be modified, and the modifications are to be mutually agreed upon between us and the contractor. So once the project is sufficiently complete, we have to apply for a certificate of construction. So our general contractor is required to secure a certificate of occupancy before requesting substantial completion inspection by our architect and design team. So the certificate of occupancy is provided by the authority. For example, we build our building in Pulilan, Bulacan. So the municipal jurisdictions over the project has the full authority to issue us the certificate of occupancy, confirming that all the appropriate inspections and approvals required by them having jurisdictions have taken place, and the project is safe to use and occupy, and the site has been cleared of our general contractors' temporary facilities, so that us can occupy the building without obligations to any authority. In addition to the certificate of occupancy, our general contractor must submit all the required guarantees and warranties from the manufacturer of equipment and materials and the specialty subcontractors and installers used in the building. For instance, the manufacturers of roofing materials, windows, curtain walls, mechanical equipment, and some more. Warranty products for a specified time period, for example, within 6 months or within 1 year period time. Final completion inspection, our general contractor carries out all the corrective works identified during the substantial completion inspection, and so inform our architect or consultants for final inspection of the project. So if the final inspection passes, certification for final payment is issued by the architect, which entitles the contractor to receive the final payment from us. Record documents, as-built documents. As previously stated, minor design changes are often made during the construction of a project. These changes must be recorded for the benefit of us, owner, should we wish to alter or expand our building in the future. So therefore, after the building has been completed, our general contractor is required to provide a set of record drawings, previously known as as-built drawings. These drawings reflect the changes that were made during the course of construction by our general contractor. So in addition to record drawings, record specification as well as set of approved shop drawings are usually required to complete the record documents package delivered to us developer.